Recap the concepts of quadratic equations. So we are looking at quadratic equations in one variable. Now the standard or general form of a quadratic equation in one variable is ax square plus bx plus c equals to 0. My variable is x and the abc values are actually some real numbers and the a value is not equal to 0. Because if the coefficient of x square is 0, then it does not remain a quadratic equation anymore. But the b or the c values can be 0, and if the value of c is 0, we will get an equation like ax square plus bx equals to 0. That is known as an unaffected quadratic equation. And if the b is 0, we don't have the middle term x, we will have some equation like ax square plus c equals to 0, and that is known as a pure quadratic equation. Okay, now a quadratic equation can have two solutions or two roots. The meaning of solution and a root for an equation is the same thing. So the number for which, if we substitute the value of the variable, the equation will be satisfied. That's the solution or the root. Now we can solve a quadratic equation to find what are the solutions or the roots in different methods. In the ICSE syllabus, you need to learn two methods. One is factorization and another is using quadratic formula. Now if we want to factorize, the method is known as splitting the middle term, because we have a quadratic trinomial on the left side whenever we have the standard form of our quadratic equation. If you remember the procedure for splitting the middle term, first we need to multiply the coefficient of x square and the constant term. So I have written an example here. Here the coefficient of x square is 3 and the constant is minus 3. So the product will be minus 9, and we have to split minus 9 into two numbers, so that product is minus 9 and the sum will be minus 8. And if we do some trial and error to check for some combinations, here we find that if I take minus 9 and plus 1, product is minus 9 and the sum is minus 8. So therefore the middle term minus 8x can be split as minus 9x plus 1x or plus x. And then we factorize it normally and we will get a product where we have x minus 3 multiplied by 3x plus 1 equals to 0. So when any two things multiplied together gives the result as 0, then either one of the things can be 0. So we split it and say that either x minus 3 equals to 0 or 3x plus 1 equals to 0. And then these are linear equations. If we solve them, we get one value each. For example, here we are getting x equal to 3, or x can be equal to minus 1 by 3. So we will get two solutions or two roots for a quadratic equation. Now the same quadratic equation could have been also solved using the quadratic formula, where the formula states that when you write a quadratic equation in the standard form, you have to note down the a, b and c values, and then the solution will be x equals to minus b plus or minus square root of b square minus 4ac whole divided by 2a. So for example, in the previous equation, which was 3x square minus 8x minus 3 equals to 0, if I compare with the standard form, the a value is 3, b value is minus 8 and c value is minus 3. And if you solve it, if you apply these values, if you substitute these values in this quadratic formula, you will get the same solution or the roots as we have got from factorization. Now in this quadratic formula, there is a square root of some quantity. So that quantity is known as the discriminant. The b square minus 4ac value is known as the discriminant of the quadratic equation. That quantity will help us identify, even without solving the entire equation, whether the quadratic equation will have real roots or not, whether we will have real roots, imaginary roots, and if we have real roots, will they be equal or will they be unequal or distinct. So if suppose in the quadratic formula x equals to minus b plus or minus square root of the discriminant whole divided by 2a, in case my discriminant is greater than 0 or it is positive, then I will get two distinct real roots. I will have one root as minus b plus square root of discriminant by 2a, or minus b minus square root of discriminant by 2a. So if the discriminant value is a positive number more than 0, then these will be two real roots and they will be distinct or unequal. So that's the criteria. And even the reverse is true. If we know that a quadratic equation has two real and distinct roots, I can claim that the discriminant will be positive or more than 0. Now the second possibility is that if the discriminant value is equal to 0, then under root the square root we have 0. Square root of 0 is 0. Then the roots or the solution of the quadratic equation will become x equal to minus b by 2a or minus b by 2a, which is exactly the same number just written two times. So we will say that when discriminant is 0, we will have two real and equal roots. And the last possibility, if suppose the discriminant value b square minus 4ac is less than 0 or if it is negative, then we know that square root of a negative number will not give me any real number. It's not possible. So I will say that in that situation the quadratic equation will not have any real roots. So there will be no real roots, but there will be imaginary roots. Imaginary numbers you can learn in grade 11. So imaginary roots will be obtained, or the same thing we can say that there will be no real roots. Now let's say that the discriminant is positive but it is not a perfect square, then square root of such a number will be irrational. So eventually the roots will be irrational. Real numbers can be rational or irrational, but if the discriminant is not a perfect square, then we will have irrational roots. Now sometimes it is necessary that we express those irrational roots to the nearest decimal place or the nearest significant figures. So decimal places, I'm sure that everyone is aware, but there is this concept of significant figures, for which we need to know for any given number which digits are significant. Figure is same as digit in this situation. So in a number, which are the digits that are significant and which are not significant. It just depends upon whether the digits are 0 or non-zero. So the first thing is that if we have non-zero digits, automatically they are significant. For example, in the first number 547.62, all the digits that you see are not 0, so all the digits are considered significant. Now in case if I have zeros in a number, there are some rules to identify which zeros are significant and which zeros are not significant. Now the 0 can be either at the beginning of the number or the left side, or at the end of the number or the right side, or somewhere in between, not exactly in the beginning or at the end. So suppose if we have zeros in between, right, if we have zeros in between non-zero digits in the number, they are definitely significant. For example, if I have 500.01, the three zeros that we see are in between non-zero digits. So they are not exactly in the beginning or at the end. So these zeros are also considered significant. Of course, 5 and 1 being non-zero are also significant. Now suppose if we have zeros at the end of the number, that is known as trailing zeros. Zeros at the right side of a number. Now they are considered significant in a number which has a decimal point. For example, I have written here three numbers. Let's say 500.10. There is a 0 right at the end. it's a trailing 0 and the number has a decimal point. So the last 0 is considered significant. The in between 0 of course is significant, and all the other non-zero digits are also significant. In the second number that we see, 500.0, there are 3 zeros at the end of the number and the number has a decimal point. So all these 3 zeros are considered significant. But in the last number where we have 500, there are 2 zeros at the end, but 500 does not have a decimal point. So according to significant figure rules, these 2 zeros are not considered significant. But in the previous situations where the number had a decimal point, all the numbers at the end of the number, the trailing zeros, are considered significant. And then the last possibility is that we have zeros at the beginning of the number or on the left side of the number. They are called leading zeros and they are not significant. For example, if I have a number 0.00510, the 0 at the end is a trailing 0, it is significant. But the starting 3 zeros are leading zeros, they are not significant. Now once we identify which digits are significant, we need to apply some rounding off rules, which you must know already. Now suppose if there is a number like 0.05070, and this number I need to round off correct to 3 decimal places, then I need to check what is the 4th decimal place. Let's say if I am looking at the decimal places, I have this 0, 5, 0 and 7. These are 4 decimal places. So the 4th one is 7. So if this decimal place is 5 or more than 5, when I am rounding correct to 3 decimal places, the 3rd decimal place I will increase by 1. So then the number rounded off will be 0.051. and I have dropped the other decimal places. Now in case the same number, if I had to round off correct to 2 decimals, then I will be looking at till the 3rd decimal place, and here the 3rd decimal place is 0. So what can I do? I can just drop these extra decimal places and the number rounded off will be 0.05. Alright, now if I was rounding off the number correct to 1 decimal place, then I will look at the number only till the 2nd decimal place, and the 2nd decimal place is 5. So when I am dropping this digit, the 1st decimal place I will increase by 1. So the rounded off number will be 0.1, correct to 1 decimal place. Okay, now let's again look at the same number, but this time we are looking at the number to the nearest significant figure. For example, the given number, if I have to round off correct to 3 significant figures, first let me identify which digits are significant and which are not. I see that there are 2 zeros at the beginning, they are leading zeros, so obviously they are not significant. The digit 5 is significant, 0 is in between, so it is significant, 7 significant, and the last 0 is trailing 0 and the number has a decimal point, so it is also significant. So overall I can see there are 4 significant digits in this number, and if I have to round off correct to 3 significant digits, then the 4th digit, since it is 0, I will just drop that digit and the number will become 0.0507. 5, 0 and 7 are the 3 significant figures in this number. Now the same number, if I had to round off to the nearest 2 significant figures, then I am interested in looking at the 3rd significant figure, which is 7. Since this is 5 or more than 5, I will drop this digit, but the previous digit I have to increase by 1. So the number correct to 2 significant figures will become 0.051. Now the same number, if I wanted to round off till only one significant figure, then I will look at what is the second significant figure, which in this case is 0. Then I will drop the other digits and my answer will be 0.05. That is correct to one significant figure. The 5 here is the significant figure.